and C permutations and combinations. I want you to stop the video for a minute and write the letters A, B, and C in as many ways as you can. When you've finished, I want you to start the video again. If you've done this correctly, you should have a total of 6 different combinations. Sometimes, as in the above example, we're called upon to arrange a group of objects in a certain order, A, B, C, A, C, B, B, A, C, etc. These are all considered to be different permutations of the letters A, B, and C. A permutation is an arrangement of objects in which the order that the objects are placed in matters. So it matters which one is first, which one is second. So for example, you should have found 6 permutations or different order arrangements of the letters A, B, and C in example 1. So using our fundamental counting principle, we can calculate that. If we think about having 3 letters, there are 3 ways that I could choose the first letter. That leaves 2 ways to choose the second letter, and then 1 way to choose the final letter. 3 times 2 times 1 gives us 6. If you think of this in terms of a factorial, 3 times 2 times 1 would be 3 factorial. So in example 1, we found the number of permutations of 3 objects, the letters A, B, and C, and we took them 3 at a time. In other words, we wanted all of these. A shorthand notation for that looks like this, where we have permutation of a certain number of objects taken a certain number at a time. So let's look at example 2. This time we need to pick a president and a vice president of the class. And let's assume that there are 16 people in the class. In how many ways is this possible? So we can look at this again in terms of being a permutation. So this would be a permutation of 16 people, but I'm not choosing all 16 this time. I'm only going to choose 2. In this problem, we find the number of permutations of 16 objects taken 2 at a time. So again, if I'm going to look at this in terms of fundamental counting principle, I would have 16 ways to choose my president, and that would leave 15 ways to choose my vice president, because I can't have the same person for both. So how might we use factorial notation? This is a little bit different because I don't have 16 times 15 times 14 times 13 all the way down. I have 16 factorial, but I have to get rid of 14 down. So I need to divide by 14 factorial. So I would have 16 times 15 times 14 times 13 times 12, etc., divided by 14 times 13 times 12, etc. This would cancel all the way down and leave us with just 16 times 15. So the way we look at permutations is in that way. Permutation of n objects taken r at a time would be n factorial divided by r factorial. Sorry, n minus r factorial, because we would need to subtract there. So what happens when n and r are the same thing, like our first example of 3 objects taken 3 at a time? Let's think about this a minute. N factorial over n minus r. Well, in this case, r is also n. N minus n would always be 0, and if you remember, 0 factorial is defined to be 1. Anything divided by 1 is the number itself. So that's what we found. All right, so let's test ourselves on this. In how many ways can the letters of the word special be arranged using all of the letters? Well, the first thing we need to know is how many letters are in the word special. So you're going to count those, and you're going to find that there are 7 letters. So what I want is a permutation of those 7 letters, and I'm going to use all of them, so they would be taken 7 at a time. This would be 7 factorial over 7 minus 7 factorial, which is just going to be 7 factorial. If, however, I'm only going to use 4 of those letters, it's a permutation of 7 letters choosing 4 at a time. This becomes 7 factorial over 7 minus 4 factorial. Working this out, we're going to get 7 factorial over 3 factorial. And this is not a bad one to compute because the numbers are fairly small. This would be 7 times 6 times 5 times 4 times 321, so 3 factorial, over 3 factorial, so that's going to cancel. Multiplying 7 times 6 times 5 times 4 would give us 840. Your calculator can also take care of this for you. If you go to your calculator and pull up just a regular calculator page, under Menu, you have the option to choose Probability. Once you've chosen Probability, we're going to choose Permutations. And that kind of looks like our setup. So if I have 7 and I'm going to choose 4 of them, the comma is right next to the O. I'm just going to put in 7 comma 4 and hit enter, and it's going to tell me that it's 840 just like we got. The larger the numbers, the more helpful it is to have the calculator to do the work for you. Alright, so let's go back to the notes now and look at our next one. This one says from 1,000 contest entries, 1 entry is chosen for first prize, 1 for second, 1 for third. So you're choosing a total of 3 out of 1,000. I want you to stop the video and set up this permutation. Use the notation, put the factorials in place, and calculate it. You should have a permutation of 1,000 items, and you're going to choose 3. So this comes out to be 1,000 factorial over 1,000 minus 3 factorial, which is 1,000 factorial over 997 factorial. And we really don't want to have to calculate those, so let's go make the calculator do this for us. So I'm doing, again, Menu. I'm choosing Probability. I'm choosing Permutations. And I have 1,000 objects, and I'm going to choose 3 of them. And so we have 997,002,000 ways that we can do that. Okay, so let's move on to combinations. Combinations are slightly different. So here's our first example. Alice, Bob, Carol, and David all want to sing the quadratic formula, but there's only room in the talent show for a trio. So you want to figure out all the possible trios. Stop the video and figure out the different possible trios. If you've done that right, you should have a total of 4 different combinations. Problem 5 is an example of what we call a combination, which is a group of objects in which the order does not matter. ABC, ACB, BCA, all of those are the same thing because they would give you the same trio of people. So for a combination, it's a little bit different. We still start with our n factorial on the top, but on the bottom we're going to divide by r factorial times n minus r factorial. So we're dividing by a bigger number to take care of removing all of the duplicates. Okay? All right, so let's look at what this does in our our example from problem 5. I want a combination. I have 4 people to choose from, and I'm going to choose a trio, so I'm only going to choose 3 of them. So working this out, this is going to give me 4 factorial over r, which is my 3 factorial, times n minus r factorial. This is a little bit more complicated to work out, but again, with small numbers like this, this is not too bad. The top looks like this. The bottom, I have 3 times 2 times 1 times 4 minus 3 factorial, 1 factorial. Well, this part's all going to cancel. 1 factorial is just 1, so we get 4. Let's look at the next one. In how many ways can a 4-person committee be chosen from a group of 17? So I'm choosing a committee. I have 17 people to choose from. I'm going to choose 4 people. So we're going to set this up with our 17 factorial, but we're going to divide by 4 factorial times 17 minus 4 factorial. So So we have 17 factorial over 4 factorial, 13 factorial, and just like we did with the permutations, our calculator can calculate this fairly simply. We're going to go back to our menu, back to probability, but this time instead of choosing permutations, we're going to choose combinations. It looks very similar, we just have a C instead of a P, so you have to make sure you're choosing the right one. In our example, we're choosing from a group of 17, and we want to select 4 people. So we have 2,380 different combinations of people that we could choose to form this committee. Alright, so let's look at this example. How many combinations can be formed from the letters in parish, taking them 3 at a time or 4 at a time? So let's start with this. We need to know how many letters there are in parish. This is a total of 6. So I would have a combination of 6, and I'm going to choose 3. So we're going to have 6 factorial over 3 factorial times 6 minus 3 factorial. And again, in terms of what you should be able to do, you should be able to write that out using the formula, and then you can use the calculator to calculate this. This is not a bad one. You could do this by hand probably just as easily, but let's practice doing our combinations. I have 6 letters, and I'm going to choose 3 of them, so that gives me a total of 20 different possibilities. So I want you to stop the video now, and I want you to do this one on your own. Your teacher will expect that to be finished when we check notes the next class period. Okay, hopefully you got that one right. Let's talk about a deck of cards. We have a little bit of a description here just in case you're not sure, but you have a total of 52 cards, 4 suits, which is 13 of each of them, and 4 of each card. So when you're drawing cards for a hand, the order that they are drawn in does not matter. Since the order doesn't matter, we would be using a combination, not a permutation. So let's think about how many 5-card hands there are possible. I've got 52 cards to choose from, and I'm going to select 5 cards. So this would be 52 factorial over 5 factorial times 52 minus 5 factorial. When I type this into the calculator, I'm going to get a very large number, over 2.5 million. So now stop the video, and I want you to go through, do the same thing with 7-card hands. Set up your factorials, use the calculator to find the value. When you're done, start the video again. Good. Okay, so the last part I want to talk about today is the permutation versus combination. Some of the harder things to do on this is to decide which one to use, because if you noticed with the calculator, you have to choose the right button because it'll calculate it differently. So how do you decide if a situation calls for a permutation or a combination? Well, the question to ask yourself is, does the order matter? If the order matters, you've got a permutation. Think of the permutation, starts with P, think of president. If the first person elected gets to be president, the second one is vice president, etc., then it matters whether you were elected first. So you're going to use a permutation. If it's just a committee, all of the committee members work together, so it doesn't matter who was put on the committee first. C, combination committee. That to me is the easiest way to keep those separate. Okay, at this point, I want you to stop the video. We're going to do this last section in class next time, and go spend some time working on your project, because that deadline's going to be here before you know it.